Hi friends, today in this video we're gonna learn about general configuration of microprogram control unit. Okay, but if you consider any control unit, the basic parts required in any control unit are the basic parts required for any CPU are control unit and arithmetic logic unit and registers. Okay, so here for CPU these three parts are the important blocks. Okay, in this video or in the coming two to three videos we will see the design of the control unit. Okay, basically this control unit can be designed in two ways. Okay, control unit can be designed in two ways. One is hardware, other is microprogram. Okay, these are the two designs with two types of design we can employ to design the control unit. Okay, basically we'll prefer microprogrammed control unit, but more frequently we use hardware. Okay, now we'll see what has in hardware and what is in microprogram. Here in hardware we have fixed type of instructions. Fixed instruction sets, and as well as we have fixed arrays. Fixed instructions, fixed arrays and fixed addressing modes. Okay, and most preferable is, or most important characteristic, it has high speed operation. It has high speed operation. Now if you remember the previous videos lecture, or if you have seen the previous videos about RISC and CISC operations, these characteristics are exactly matching to the RISC characteristics of the CPU. That means these characteristics are all RISC type design. Okay, so these are all RISC type design characteristics of the CPU. Okay, so mostly hardwired design control unit are all for RISC CPUs. Okay, the example is Intel 8085 processor. It employs the hardware type control unit. Okay, now here when it comes to microprogram, these have a micro instruction under which we have so many micro operations to perform. Okay, now here we have the example as Intel 8080. Okay, Intel 8080 processor works under, or it is designed using microprogrammed style, and these are CISC type of design CPUs. Okay, these are employed under CISC type of processors, because these are softwarely designed. These are hardware designs. Okay, now we'll see the microprogrammed control unit. That means I am stressing microprogrammed control unit. That means microprogram. It is programmed. That means it is a software type design. So now we'll deal with the CISC type of processors or CISC type of control unit design. Okay, so basically these are the terms which are required or initially before going to the general configuration. Okay, first thing is control word. What is a control word? Okay, control word is a set of control variables at any given time which can be expressed in terms of zeros and ones. That means control word is a, I can say, group of control variables which are expressed as zeros and ones. Okay, so as they can be expressed as zeros and ones under one control word, and if for a micro instructions to be executed, if I give this control word and the next micro instruction will have the following control word after this. Okay, suppose my control word is like 0 0 0 0 0 1 0, then the next two might be 1 1 or 0 1 1 or 0 1. Based upon that, for one control word register I can operate many instructions or many operations by using a single control word. Okay, next is micro instruction. These control words are mainly used for executing the execution of the micro instruction. Okay, these are the main reason for the execution of micro instructions. Whereas now for a microprogramming, these instructions, okay, we need this control word register, control word we can say. Now I am talking about the control unit. Okay, so any control unit or this control unit, okay, which is considering these binary variables in its memory. Okay, this control unit with these binary variables in its memory is called microprogram control unit. Microprogram control unit. Okay, that means the control unit and the control unit in which this memory which is allocated to these binary variables or this control word is called a microprogram control unit. Okay, after this we will see a term called micro instruction. Okay, each and every word, what you can say is, when this control word is there in the memory, word in memory, okay, this word is made up of micro instructions. Okay, micro instructions. After that, this word is built of these micro instructions. Okay, what is a microprogram? Microprogram is the sequence of these micro instructions. Sequence of micro instructions is called microprogram. Now, next is talking about control memory. Simple. The memory which is allocated in the control unit is called the control memory. That means here I can say ROM. ROM acts as the control memory. Mainly what happens is this memory is divided into two types. Okay, one is main memory and one is control. Now memory is divided into two types. One is main memory and other is control memory. Okay, here in main memory, this is used for storing programs. Okay, whenever you alter the micro instructions or the data in the program, the memory in the memory in this main, or the data in the main memory will also be altered. Okay, if you change the instructions, and the operations will be changed, and the micro instructions will be changed, as well as micro operations will be changed, and entire memory in this memory unit will be changed. That means this can be altered whenever we require. But when it comes to control memory, that memory is fixed. You cannot alter this once it is programmed. This can be altered even though it is programmed. Okay, this can't be programmed. That's why we use ROM here. ROM as the control memory. It is read-only memory. We cannot write again. That means it is fixed memory and it cannot be changed further. Okay. Next comes is about these microprogram instructions and all. So I already mentioned this microprogram is the sequence of micro instructions, okay, which consists of, or which specify the various control signals for execution of the different micro operations. Okay, that means if I have a register operations, and if I want to run a program, if I want to do a program for execution of such sequence of instructions, then I need to give the control word register, control word for that, so that my register operations will be executed further. Okay, every micro instruction in this, every micro instruction should follow the rule as fetching the instruction, decoding the instruction, and executing the instruction. This is what we have seen in the instruction cycle of the arithmetic logic unit, or instruction cycle interrupt cycle, okay, of a CPU. This is the general format. It needs to fetch the instruction, it needs to decode the instruction, and it needs to execute the instruction, produce the output. Okay, and after it completes this, it should again go back to the previous cycle, fetch cycle. Okay, now we will see the general configuration of the control unit of microprogram. Okay, so this is the general microprogram control unit block diagram. Okay, it is external input, sequencer, control address register, control memory, control data register, control word. Now if you see this, we have two registers here. Okay, control address register and control data register. Okay, control address register can used for holding the address, gives the address of the instruction, it holds the address of the register. Control data register, it holds the, I can say data, that means it holds the instruction of that particular address. Okay, now if you see this sequencer, control memory, and these four blocks, only these two are the registers. That means these two are only the timing circuits which need a clock signal. Okay, these two registers are their registers. I need to apply clock signals for both. Whereas here ROM acts as combinational circuit. Okay, that means the input for the ROM takes the inputs as address bits, and it produces output of control word. Okay, it takes the address as input and produces the output as control word. It acts as a combinational circuit here. And sequencer is called next address generator. That means once if I get an address, okay, and it went to the control memory, after it is in the data register. After my completion of the execution of the data register's instruction, it produces a control word, I need to get back to the next cycle for next address of the instruction. Okay, so this process should be in a cyclic process. It should continue until each and every instruction is completed for the execution. Okay, so this sequencer does this job. It produces the next address of the instruction to the control. It gives that to the control word register. Okay, now so sequencer is acts as next address generator. It gives the next address of the instruction to a control address register. Thereby it sends it to a control memory. Okay. After that, it gives to data register, which gives my control word as the output. Okay. Here data register, although it is executing the present instruction, okay, it fetches the next instruction and compute it and put it in a line. Okay, that means it will be ready for execution of the next instruction also, although it is doing its instruction. This is called pipeline register. Okay, it employs the principle of pipelining. That means it has its instructions in a line. One after the other, it executes the instruction and gives the control word for every register, for every instruction. Okay. Now, this is all about this microprogram control unit, or it is CISC type of register, CISC type of design of control unit. Whereas in RISC type of control unit, it is reduced instruction set control. That means reduced instruction set architecture or computer. Okay. Here we don't have more instructions. There will be less instructions and the length will be variable. Most of the computers employ this type of instructions. Okay, the basic example for this RISC type of instruction is timing and control unit of which has number of logic gates and a 3x8 decoder, 4x16 decoder, and as well as it is having four-bit sequencer, and my address format I is connected to a flip-flop. Okay, and these are interconnected. Okay, outputs are taken from these two logic gates. So this is the example for RISC type of design of control unit. Okay, here we use more hardware than software programs. Okay, that means the programming will be less, but registers will be more here. Okay, whereas here in this the programming instructions will be more and registers will be less. But here the main advantage of this is once the order is set, and if you want to change the program, then there is no need to change the entire hardware. Just changing the micro operations in the micro instructions will be sufficient for us to change the entire program. Okay, this is the main advantage with the microprogram control unit than this hardware type of control unit. Okay, but we use this more because of its flexibility and its characteristics. Okay, which of more registers, that means less transistors are used here, more accurate, and even CISC type of processors, they use memory. Here we don't need of memory, here we need just registers, as we have less chip size. Okay, these characteristics are already discussed in the previous videos. Okay, that's all for this video. Thank you.